A very good morning to all of you. I am Ghanshyam Bajaj, a representative of Shivjyoti Convent School. I hope you all are doing very well. Today we are going to start Unit 1st, Electrostatics, Chapter 1, Electric Charges and Field. In this video, we will try to cover electric charges, properties of charge and Coulomb's law. We will discuss about electrostatics. What is electrostatic? It is the branch of science in which we do study of charges at rest. Electrostatics, you can break it into two parts, electro and statics. Electro means charge, static means rest. So electrostatics, it is the study of charge at rest. What is charge? Charge, it is an intrinsic property of particle by which it applied electrical force. You know very well, positive repel each other, positive negative attract each other, negative repel each other. So these are the charges which apply electrical forces. Now how object can be charged? Object can be charged by rubbing because it possesses net electric charge. For example, if you comb your hair again and again, then comb will get charged. If you take, now we'll perform an activity. If you take a plastic ruler and you will rub it with your hair and then bring it close to some tiny pieces of paper. So now you will see that it will start attracting tiny papers. It will attract due to static electricity. Another activity also you can perform. You can take glass, you can take silk, you rub glass with silk. Now glass will get positive and silk will get negative. So if you take both glass rods, so it will repel each other. If you take both negative silk rod, it will repel each other. But if you take glass positive rod and silk negative rod, so it will start attracting. So now conclusion is that unlike charges attract each other and like charges repel each other. Now we'll discuss what is the SI unit of charge. SI unit of charge is Coulomb, and the CGS unit of the charge is state Coulomb, and 1 Coulomb equals to 3 into 10 to the power 9 state Coulomb. Now we'll discuss what is conductor and what is insulator. Conductor, in which charge can flow easily. As you know, metals are very good conductor. Insulator, almost no charge flow. Plastic, rubber, wood, they are insulators. Now what is the charge on an electron? The charge on an electron is minus 1.6 into 10 to the power minus 19 Coulomb. It can be denoted by E minus. And what is the charge on a proton? Same, but in positive, 1.6 into 10 to the power minus 19 Coulomb, E plus. Now we'll discuss properties of charges. First property is that like charges repel each other, unlike charges attract each other. Charge is additive, charge is conservative, and charge is quantized. Now we will discuss conservation of charge. Charge is always conserved in an isolated system. Charge neither be created nor be destroyed, just it can be transferred from one body to another body. Now we'll discuss quantization of charge. Electric charge is always an integral multiple of charge E. E is quanta. Electric charge is always an integral multiple of charge E. Q equals to Ne, where N equals to 0, plus minus 1, plus minus 2, plus minus 3. So quantization we can understand by taking this activity. There are two bodies A and B. We rub each other. Suppose charge is transferring from A to B. So you know very well, 1 electron can be transferred, 2 electron can be transferred, 100 electrons can be transferred, million electron can be transferred. But 1.5 electron cannot be transferred, half electron cannot be transferred. If electron is transferring, then full electron will be transferred. So it will transfer integer multiples. Now we will discuss additive property of charge. Charges are scalar, so they can be added algebraically. Suppose Q1, Q2, Q3 Qn charges are present, then total charge will be equal to Q1 plus Q2 plus Q3 Qn. We can understand by taking this example. Suppose a body contains 5 Coulomb charge, 5 microcoulomb charge, 3 microcoulomb charge and 2 microcoulomb charge. The net charge will be equal to 10 microcoulomb charge. And another body which contains 5 microcoulomb minus 3 microcoulomb and 2 microcoulomb. So net charge will be 4 microcoulomb. So now we'll discuss Coulomb's law. What is Coulomb's law? It states that the force exerted between 2 point charges is inversely proportional to square of the distance between charges. Force is inversely proportional to square of the distance between charges. Force is directly proportional to product of magnitude of two charges, and this force acts along the line joining the 2 point charges. So F proportional Q1 Q2, F proportional 1 upon R square. By combining this equation, we'll get F proportional Q1 Q2 upon R square. If we remove proportional, we'll apply equal with constant. F equals to K Q1 Q2 upon R square. Instead of K, we can write 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Epsilon naught value is 8.85 into 10 to the power minus 12 Coulomb square Newton inverse meter inverse 2. It is epsilon naught is called permittivity of free space, and K is called electrostatic constant, whose value is 9 into 10 to the power 9 Newton meter square Coulomb inverse 2. Thank you very much. Have a wonderful evening.